And so this one, we're going to go back and look at f of x equals x squared, and then under what domain will the inverse relation be a function? So the first thing we'll look at is if this is the original function, where is it going to be a problem? So it's basically any point on one side is going to match the other side, right? So essentially what we're going to do is we're going to eliminate one of the sides. So if we eliminate the left side, we're looking at a domain of the original x greater than or equal to 0. All right, so if we only look for the inverse of this, then the inverse will be just square root of x, not plus or minus square root of x. Now that is a function. All right, so now let's look at the you try it question. So I want you to pause it, try it, and come back and check, but you're just taking these functions and attempting to get the inverse, and then identify only part of it that would be restricted. All right, so the first one I did in red, part A, I factored first. I got y equals x plus 4 squared. That domain we're going to restrict to x greater than or equal to negative 4. Reason being is that plus 4 would move everything left 4. So that would be where the vertex is, which would be the inflection point on where you only want one side. And then flipped x and y, solve for y. You got y equals square root of x minus 4. The inverse function needs a domain of x greater than or equal to 0 because you can't have a negative under a radical. Part B I did in blue. That one is shifted down 9, so it didn't move left or right at all. So the domain will be restricted just x greater than or equal to 0. Flipped x and y, solve for y, got y equals square root of x plus 9. And that domain needs to be x greater than or equal to negative 9 because you can't have a negative under the radical. All right, let's look at example 4.